Chemistry, this is the answers video to day 51, Basic Waves. This is a new unit called Advanced Atomic Theory, so we're going to learn something about atoms that we have not learned up until now. So this was assigned on Tuesday the 8th. It's due on Monday, November the 14th, and the not accepted after date is after the Thanksgiving break. All right, so let's get going on this. So waves is a topic you may have learned in physics. And what waves are is they are the movement of pure energy. So watch the lecture video, that'll explain what they are and the different types of waves. But one thing that we deal with in this unit is the fact that waves are not just waves. Electromagnetic waves can actually have two forms. One is as a wave, which is this up and down roller coaster type of continuous motion. The other is as a particle, and that's called a quanta, or if it's in light, it's called a photon. It's like a little ball of energy. So it has the characteristics of both a continuous wave that goes on and on and on like that, or as a photon. There's three equations we're going to deal with. We're not going to deal with a lot of these. In some classes I teach these, but not in this class. They're not tested on the AP exam, and I really don't teach them anymore. But the first is called the electromagnetic wave equation. And what it says is this c, which is not a variable, it's the speed of light. It's 2.998 times 10 to the 8 meters per second. It's got to be equal to the wavelength. So lambda, this funny looking thing, is the wavelength. It's how long the wave is. Again, go to the lecture video. And this nu, it looks like a V. It's actually, the letter nu is the frequency of the wave. It's how many times it goes up and down, cycles through each second. So if the wavelength gets longer, the frequency becomes a shorter frequency, a smaller number. If the wavelength is very short, then the frequency is a higher number. In other words, it cycles up and down a lot faster. And so those two are related inversely by this number. They both have to multiply to be this number. We'll just call it 3 times 10 to the 8th. Now, the two equations that relate this idea of waves being both waves, light, let's just think of light in this sense. Light being both a wave and a particle are these two equations. And what it's saying is that the energy, that's E, of a photon. And I could have written that here, but it's usually the equation is written like this. The energy of one photon, I'm going to put a 1 there, is equal to something called Planck's constant, which is this number. It's a constant, it never changes, times the frequency. There's that frequency, that letter nu again. So it relates, frequency is a characteristic of a wave, how many times it goes up and down, and E is how much energy is in one of these little balls of energy called a photon. Now, you can also have the energy of a photon, express the energy of a photon as, it's basically just rearranging these two equations, doing a little algebra, and you have Planck's constant times the speed of light over the wavelength. So it's the other thing over here. So a wavelength is also a characteristic of the wave nature of light. It's how far it is between the top of this wave and the top of that wave. It's called the wavelength. So if you know the wavelength, you can, these are both constants, they don't change, H and C, you can know how much energy is in a photon. Okay? Alright, so we're going to go ahead and just do some basic exercises with waves here. I think I'm going to do them all with you here, because I want to be sure you come out of this knowing for sure how to do this. Alright? And this assignment is due on Monday the 14th when we get back to school from this weekend. So here we go. So you're standing above a wave at crest 0. So you're at point A. That's stationary. It doesn't move. But here's crest 0 of a wave right here. When your watch reads 0 seconds. So it says that right here. 2 seconds later, the wave has moved to the right over here, and you're standing above crest 4. So you're staying in the same place, but the wave, it says wave direction has moved to the right. So it's like a before and after picture. So here's the before, and then here's after 2 seconds later. So the question is, it says answer the questions below about this situation. Okay, so I'm going to go ahead and flip the page here. Okay, so using the diagram above, answer the following. What is a cycle of a wave? So this is a more general question. It doesn't just apply to this wave. So what is one cycle? A cycle is when you go from a point on one of the waves to the exact same point on the next wave over. The easiest thing to visualize is when you start here and you go down and back up again. That's one cycle. It's one complete movement through the wave. It could be from here and then I go up and down and back up to there again, but that's a little more complicated and confusing. So if you just think of starting at a crest, go down and come back up to the next crest, that's one cycle, okay? So let's go ahead and write that. Okay, so a cycle is a movement from the crest of a wave to the crest of the next wave over. Okay, so again, starting right here, you go down and you go to the crest of the next wave over. All right, what is the wavelength of a wave? Okay, so let's write that out first and we'll read it. Okay, so let's go ahead and do a little diagram here. So if I draw this, let's just draw a wave, couple crests of a wave. So the cycle is down and back up. The wavelength is a straight line distance from here to here, okay? And it's measured in the units that we would measure distance in, which would be meters, or micrometers, or nanometers, or some form of meters. So it's a straight line distance, okay? So this is wavelength, and this is a cycle. Alright, so it says the wavelength is the straight line distance from the crest to the crest of the next wave. Okay, so just what I said, from the crest to the crest of the next wave. Okay, what are the crest and trough of a wave? Alright, so let's just draw little pictures with this. It makes more sense. Okay, so this is a crest, and this is a trough. But the only place you ever hear the word trough is a pig trough. It's what pigs eat out of. They call it a trough. It's where their feed goes. So that's the way it's spelled, and it's the bottom of a wave. All right, that's all you really have to do. What is the amplitude of a wave? So let's just write crest is top and trough is bottom. Okay, what is the amplitude? Amplitude. Okay, so again, we're going to draw a little diagram here. Okay, and here's the central axis. So the wave is going as much above this axis as it is down below. It may not look like the way I drew it, but it should be. It should be equal distances. So we just think of it as the distance from the central axis, that's this, to the crest of a wave. Whatever that is, that's the amplitude. It's not from the bottom of the wave, from the trough to the crest. It's from the central axis up. And this would be the same distance going down as well if I drew that a little more neatly. So amplitude is a distance from the central axis to the crest of a wave. How many cycles are how many cycles from crest 1 to 4? Okay, now we're getting into the specific problem here. So let's see. So from crest 1 to crest 4, there's 1, 2, 3. 3 cycles going from 1 to 4. Don't make the mistake of counting crests. 1, 2, 3, 4. That's wrong. It's how many cycles does it do? 1, 2. Let me start again. Start at 1. 1, 2, 3. Okay, so okay, let's go to the next one. If the distance from crest 0 to 4 is 12 meters, what is the distance of one wavelength? So let's just look at this. From 0 to 4, we're going to say in this example that this distance is going to be 12 meters from there to there. Okay, so that's 1, 2, 3, 4 wavelengths. Remember, wavelength is the straight line distance. Okay, so wavelength, so get used to this, lambda equals the 12 meters is 1, 2, 3, 4 wavelengths. So 12 meters divided by 4 wavelengths, and that's in meters, is going to equal 3, I should just say 4, is going to equal 3 meters. So each of these is 3 meters, 3 meters, 3 meters, 3 meters. So that's a wavelength is 3 meters, okay? 3 meters is one wavelength. Okay, at time t equals 0, crest 0 is below you at point A. 2 seconds later, crest 4 is below you at point A. What is the frequency of the wave? So that's really basically just this problem right here. So at time 0, crest 0 is below you. 2 seconds later, crest 4 is below you. So how many cycles is that? It's 1, 2, 3, 4. Okay, now frequency equals some number of cycles per second. So we said that was 4 cycles, and it took 2 seconds. So 4 divided by 2 is 2, and the unit of measure for frequency, this is in the lecture video, is hertz, which is abbreviated Hz. Or another way to express the unit is 2 times 1 over seconds. That's another way to express the units of measure for frequency. Or mathematically, 1 over something is equal to that thing, s to the minus 1 in this case. Okay, so that means the reciprocal. This is the same as this. It's 1 over s. So those are 3 ways to express frequency, and in this case the answer is 2. Alright. If the wave has a constant speed and the frequency of the wave increases, how does this affect the frequency of the wave? And I changed that. I made a mistake there. That should have been wavelength. Obviously, frequency increases, the frequency increases, right? Okay, so you use this. Remember that c is a constant equals lambda times nu, which is the frequency. So it says at constant speed, okay, and speed of light is constant speed, it never changes, and the frequency of the wave increases. So if this goes up, and these two numbers have to multiply to be c, then this has to go down. If you want to use specific numbers, if this goes up 2 times, then what you have to do is divide this by 2. Alright? So this goes up, so this goes down. So wavelength decreases. Okay? How does this affect the period of the wave? Alright? So period is t, again you got to watch the lecture video, is 1 over the frequency, 1 over nu. Alright? So let's just pick some numbers. If the frequency, it says if the frequency of the wave increases, let's say it goes from 2 hertz to 4 hertz, that's increasing, then the period in this case is 1 over the frequency. It would be 1/2 second, and period is measured in seconds. It's some unit of time, and this would be 1/4 second. So as the frequency goes from 2 to 4 increases, the period gets smaller. It goes from 1/2 to 1/4. So you can just say period gets smaller. Alright, and how does this affect the amplitude of the wave? The amplitude is the height. There's a relationship between frequency and wavelength and period, but there is no relationship with amplitude. How tall the wave is not affected. So you could just put no effect. Okay. Okay, what type of waves travel from the sun? Some students were coming up with different answers that they thought made sense. It's simply electromagnetic. Okay, and 11, what is the speed of an electromagnetic wave, and does an electromagnetic wave require a medium? Okay, so let's write that out. Okay, so electromagnetic wave travels, the speed of an electromagnetic wave is 2.998 times 10 to the 8 meters per second. That's the speed of light. That's true of any electromagnetic wave. And does it require a medium? Okay, an electromagnetic wave does not require a medium. That's why they can travel from the sun to Earth in outer space where there's nothing. It's just an emptiness, a vacuum is what it's called. And so they don't need a medium to travel. All right, so that's every single answer for this assignment. I want to be sure you understand these basic concepts of waves before we go on. All right, so this assignment is due on Monday.